Right, I think we'll continue, resume. So before break, I think I told you about the decorator, how to create a decorator, very basic decorator, right? Using a function that creates a wrapper. If you're creating a function as decorator, this is what you do. If you want to create it as a class, in most cases, if it's a constructor expression over here, right? You make sure that you implement call method which works as wrapper. Whatever wrapper does in this function equivalent is done by the call method here. We'll call the original function and do any kind of operation, right? Now I'll show you some examples of decorated chaining here. Save this as another copy. Let's assume there are two decorators. For now, I'll take functions itself for simplicity. There's one decorator that actually converts to uppercase, and maybe there's another decorator which will actually add some, let's say HTML-like tags, let's say italics of FL. And all it does is maybe def wrap of star args, star keyword args. In this, it will return maybe an italics tag plus the original function's output plus a closing italics tag, and it'll return wrap. For call greet, just one trying to call greet over here, just see the output. Oh, did I run this? Right. Okay, it will print now output. Why? Because I'm not printing the output, right? I'm not printing it. I'll do one thing. I'll just say print of greet. Print of greet function. It only prints hello world. If I add a decorator, let's say to greet as 2_upper, it decorates it to generate output in uppercase. Instead, if I add a decorator called italics, right, it decorates a function with the italics tag. But I can actually add two decorators like this. It's perfectly fine. This is called decorated chaining, okay, or chain decorators. You see this? Both decorators are applied.
Which one will execute first? It doesn't matter.
No. It goes in a particular order. Just see the output now. Look at the output this time. Look at the I tag with capital letter.
Okay.
Right? Now if I just try to interchange, right? Let's interchange this. I put italics up, 2_upper below.
Oh, it's from bottom to up.
Yes. See this? I tag small letters now. So you know how this works. Actually, it's like this. When you look at this decorator, there are two levels of wrappers. Why it is called decorated chaining is because the original greet function in this case, right, the greet function object, is being wrapped by a wrapper provided by 2_upper. 2_uppers wrapper, right? 2_uppers wrapper. This 2_uppers wrapper is passed as an argument to italics, right? An italics wrapper will wrap 2_uppers wrapper. There are two wrappers for the original function now. What do you want to say? So it's a greet, right? This function object which is created is passed afresh to 2_uppers argument, as 2_uppers argument. 2_upper takes this argument, creates a wrapper, and it returns a wrapper. What a wrapper is written by 2_upper is passed to italics, right? Italics will wrap the 2_uppers wrapper, and whatever italics returns, that is what greet will be assigned to. So you're actually calling greet, right? You're calling italics wrapper. Italics wrapper calls 2_upper wrapper. 2_upper wrapper calls original greet. The return path, what happens? The greet's return value is first converted to uppercase. Then that is given to the italics wrapper. The italics wrapper will add the I tag in small letters, right? And then return the output. Right? A multi-level gift wrapping is similar to that. Clear with this? Right? So this is how you can chain decorators. And these decorators can do different work. Right? Maybe one decorator does logging, one decorator does convert to uppercase. Can be anything. So we can add as many decorators. All the different cross-cutting concepts. Any questions? Doubts for this? Clear? Right? This is what you call as decorated chaining. But there's another interesting aspect over here. You can see both 2_upper and italics have something very common. You know what they do? They're worried about the return value of the original function. They decorate the return path. Am I right? So you know the decorating return path. One is just converting to uppercase, other is just converting italics, right? Can instead also create one more version. I'll just call this as parameterized decorator. What is a parameterized decorator? I'll show you what this. Instead of creating two different functions, decorator functions, this time I'll create just one decorator function called style. Okay, so here I'll simply say for greet, I'll say style of italics like this. For welcome, I'll say style of maybe upper. Now closely observe the previous use cases, all the examples I showed. Is there a, where is it? All the others, where are they? Okay, I lost. Hang on. All of these things. In these examples, do you see? Am I using open close parenthesis here? I'm not using it. But it's anyway getting called by Python because of annotation syntax. Am I correct? If at all you put an open close parenthesis and you pass any arguments, this is a function that returns a decorator. It is a function that should return a decorator function. Okay, now you'll see 3-level nesting. Okay, now you need to be more awake. Okay, that's why I left you for break. Let's see. I'll say style of, I'll say yes. Okay, in this case. This will have an actual decorator. I call it decorator of target function. The decorator, what I do is I'll say if yes double equal to italics, right? Def wrap of star args star keyword args return, okay, an I tag plus the target function's return value plus closing I tag, right? Elif yes double equal to upper def wrap of star args star keyword args. Here I'll say return the target functions output in uppercase. Okay, as here I'll say return wrap. Okay, so you can see, and what I'll do is in here I'll say return decorator. I'll show you the output first. I'll just I have print greet. I'll say print of welcome. Oh, welcome missing one argument and passes argument. Hang on. Welcome of select or something. Oh, I just saved it, did I? Okay, original function, right? I forgot to do this. I say function must also be passed with whatever arguments you get. I forgot that, right? Whatever arguments wrapper gets, we faithfully pass on to the function. What you see here is that I'm using the same decorator, looks like, right? Style it in italics, style this in upper. This is called parameterized decorator. Why? This is like a decorator syntax, an annotation with some parameters. What argument should we take? Whenever you have an open close parenthesis with any arguments, this is a function, right? You can see on top that function. I just remove some blank lines which is there here so I can see this close, right? For example, here it is a style of italics. Style function is called by us. We are calling style function, passing italics as an argument. So s is equal to italics. What does this function do? Defines another function called decorate, returns a decorate. Defines decorate and returns it. What a decorate is returned, this annotation syntax will make Python call the decorator, passing this function as an argument. The decorator takes the target function as an argument. And this decorator, via closure scope, necessary scope, will check whether s is equal to italics with italics, create a wrapper differently. If s is equal to upper, create a wrapper differently and returns a wrapper. The original greet function and welcome function point to the wrapper appropriately, right? This is a typical signature of a parameterized decorator. Clear? Understand it?
What is the
What
equivalent
the-
of
Yeah.
assignment for this annotation add style of italics, right?
Yeah.
So only if you have add style, it is like style equal
Style
to,
itself is yeah.
So now what will be the assignment?
Oh, it's like style is equal. No, if I say at the rate style like this, right? If I say at the rate style, then this won't work. Okay. In the previous example I showed you, right? Maybe if I had two upper also.
Equal to style of greet.
Yeah. But in this case, it will be greet is equal to style of, okay, italics, okay, whatever it returns, call this with greet. This is what is getting called. A function returning a function, whatever function return, call the return function passing this target. The previous, this is how this is the example, this is the equivalent. Previously, I remember I showed you I was manually wiring the decorator. What I said greet is equal to just 2 underscore upper of greet, right? I simply said 2 upper, but this one, call style with argument, whatever it returns should be a function which will decorate the target function. So call that function with the target function as an argument. Clear? So you can see 3-level nesting here. So you should know that if at all you have a parenthesis here which takes any arguments, right, then this must be a parameterized decorator. That means this function should return a decorator. What if I want to create this like a class? What do you want to create this class, style as class? How do you do that? And tell me how to do it as a class? Def init. And then
Function.
target function. Are you sure? Yes.
Style, that one.
Yeah, I want to implement this as a class. How do you do that?
You need to call the argument first, which style.
Style. Right? The actual style, yes.
And function.
Here you will say self dot style is equal to s. Then this returns an object.
Call.
The object you should implement call. The decorator is actually done by call this time. Call will take the target function as an argument. Target function is an argument. So in call, you will create a wrapper. You will say if self dot style is equal to italics. You will define a function, whatever logic you had, right? Define a wrapper of star args, star keyword args, which will return I tag plus function of star args, star keyword args, right? Plus the closing I tag, let's say. Elif self dot style is equal to, right, upper. Define a wrapper with star args, star keyword args, which will return the original function of star args, star keyword args converted to uppercase. And this call should return this wrapper. If you want to have a parameterized decorator implemented as a class, this is signature. Call will not directly replace as wrapper. Call will be a decorator now. Call method works like a decorator in this case. And that should create a wrapper and return the wrapper. Clear? So if you just try this now, I can say at the rate style like this with capital S, indicating it's a class-based decorator. Right? I'll paste this code for you. Just have a look for your reference. Take this from here, from the clipboard, right? Any questions? Doubts so far? Let me tell you, if you understand decorator and AOP semantics in Python, every other language look like small children. In many other languages, doing this is not easy. Java, annotations are not very easy. Using annotations is easy. Creating one is difficult. Try creating your own annotation in Java. You have to worry with Reflections API. You will get neck deep in Reflections API, right? But here, it's pretty straightforward. He's inspired from Java, but they made it very simple, more practical. Any questions? Doubts for with this? Okay, let's check how confident you people are. Remember yesterday I gave you one exercise called PyShell. Python shell exercise. You know what's the problem with that? I'll show you that PyShell exercise which I had shared yesterday. I hope I have that here. No, I don't think so. It's there in yesterday's example, right? MNOP, yes, P, yeah, this is the one, right? Yeah. This exercise I gave you yesterday where I created a couple of functions and I wanted to implement this code, right? Logic. I think we had also implemented. How did we implement it? We created a dictionary, am I right? And we actually started populating a dictionary. Now, creating a function for every command is separate. It's okay, but adding to dictionary is cumbersome for me. Now I'll show you how I want this code to work. The new exercise, a PyShell, right? I'll write this code and I will share it with you. I think I should be already having it. Today's examples. Yeah, what happened? Now what I want to do is, okay, forget about all this documentation strength. Oh, okay, all these are not required. You're supposed to implement this class called PyShell. This is a to-do. What I'll do is, I'll say shell is equal to PyShell, okay, like this. And then I'll just say @shell dot command of list. Here I'll say @shell dot command of who am I. And here I'll say shell dot command of date. And here I'll say shell dot command of exit. What I mean to say is that I have a function, right? This function must be called when the command is list. This function must be called when the input command is who am I. And this function must be called input command is date. And yes, to make it work as a proper shell, I'll also add some more interesting things. Yes, one more interesting annotation I want to add is @shell dot invalid. If the command is invalid, you call this particular function, right? And the last one is getting user input. To get user input, I should be able to say @shell dot input must call this particular function. The main program, I say PyShell dot run, it should work. Now I'll tell you what all methods are there, what all methods are required. PyShell, right, is an object which I created here. Shell is equal to PyShell, and not PyShell dot run. I'll just simply say shell dot run. Right? So I just created an object called shell is equal to PyShell. You should implement the class with all these features. Command method will work like a decorator, which will register a new command for a function. All is command method, right? Register a new command for a function. Invalid is to register for invalid commands. Input for registering user input. So when I call shell.run in a loop, right, it should keep calling this particular get input. What are get input returns? See get input, right? You can see input PyShell split. Get input returns a list. The list first token is a command. Result tokens will be arguments to the particular function, right? Can I just try implementing PyShell to make this work? I'll paste this in the clipboard. You can take this exercise from the clipboard, right? And implement this. Try doing it.
I gave you what is expected behavior, so you know what is to be done, right? Actually, this PyShell is not a decorator. PyShell is simply an object, it's a class. Now what are the decorators in it? There are 3 decorators. Decorator number 1 is command, it's a parameterized decorator. Decorator number 2 is invalid command, right? Decorator number 3 is input in the class.
Done? Anybody? Where are you stuck?
I know, it's like learning Python is like learning chemistry. Easy to understand.
But trying it out, risky. Okay, I'll come to this. Okay, how do you create this class? The init method. We don't know what to do with the init method. Am I right? Because we are initializing this here. We're just initializing it. Should we initialize anything here? We don't know. So for now, I'll just leave it blank. We don't even know whether we need init. We'll worry about that later. When I say @shell dot command of list, what is this? It's a method. Am I right? Shell dot command is a method. And a method is a parameterized decorator. What does it mean? This method should return a function that decorates a target function. Am I right? So, how should command look like? Def command, right? Of self followed by whatever the command is. This is actual command, am I right? Whatever the command is, that's called as C, for example. And what should command return? Because you're calling that method, it should return a decorator, right? So you know always, when you are calling the function, it's a function or method, it should return a decorator. So I'll call this as decorate of target function. What we do here, you tell me in a while, but I should return this decorate. Am I correct? So it's a shell dot command of list. When I say shell dot command of list will be passed as the second argument to command. It's an instance method, am I correct? Instance method, whatever argument is there, the second argument, C is equal to list. This creates a decorate function, returns a decorator. What decorate is returned, the annotation syntax will call decorate, passing list directory as an argument. Passing list directory as an argument, alright? So FN will be list directory. What do you do here? Self dot C.
Before that, we have
We still need a dictionary, don't we? We still need a dictionary, am I right? We need to create a mapping for so and so command, so and so function. What you do here, now within it, that's a self dot commands is equal to empty dictionary. Okay? Here I'll say self dot commands of C is equal to Fn. Am I correct? What does this do? Basically, every time I call command of list, it's going to accumulate into dictionary. For this command, call this function. For this command, call this function. Understanding it? The next, I have self.invalid. So what is invalid? Here it is. There's another decorator, not a parametric decorator. Invalid of self target function. What should it do? Self.invalid command is equal to the target function. Input of self function self dot input fn is equal to that function. Okay, I'll say invalid fn, invalid function. Okay, make it more intuitive. I'm storing them all as instance attributes, right? Singleton instance methods in this case. Then finally you need to have a run method. So you have shell.invalid, shell.input, both the decorators. Run is not decorator, simply a method. What should you do in run? In run, I should say while true. Okay, the while true loop. I'll just say args is equal to self dot input fn. What is registered as input function, right? Call it. So the input fn is nothing but this input fn, right? Get input. What does it return? Returns a list. See? Split. Right? Input of PyShell, get whatever string, split it, return a list. Whatever list is returned is actually in args. The 0th element of arguments will represent the command, the rest of it will be the argument. So I can just specify, I can now say over here, self dot commands of, dot get rather, right, of self dot, I can just specify args of 0 or self dot invalid function, return the invalid function. Whatever you get, pass on with self, star self dot self dot. Okay, so this is done. Let's try running this. Oh, sorry, this. Okay, okay, it's in a different folder. Exercises, I guess. PyShell prompt list dot PyShell has no attribute args. PyShell object has no attribute args. Oh, did I say self dot args? Is it? I have mistake. Star args. Mistake. Silly mistake. It's not instance attribute. It's simply a variable. Right? Silly mistake. Right? The beauty is, if you want to implement a new command into the shell, it is very elegant. If you want to implement a new command, let's say pwd, to print the current working directory, all I could do is, I could say here, this place, def get cur der, okay, of star args. Maybe I'll say from os import get cwd, print of get cwd. And this I want to make it work for command called pwd, so I'll simply say @ shell dot command of pwd. You don't have to worry about going and filling up a dictionary manually, like I showed you yesterday. Yesterday, what we did, we filled up a dictionary manually, and then we actually added a command, right? Here, this particular annotation intuitively says for pwd command, this is the function to be executed, right? Let's see this. And this again. See this PyShell prompt. If I just type pwd, see this. Who am I? Any other command? List, exit.
No.
Oh, exit is not working. Strange. Why? Did I make it? Oh, I didn't implement exit, is it? Okay, maybe. Yes.
System.
Oh, I should say here exit of 0 will not work in this particular prompt, in this IPython prompt. Okay, that's the reason. If you do it in a command line, it will work. Clear? Yeah.
To the top.
Okay.
Here, generally for every decorator function is
Yeah, for every.
decorator FN.
Yeah, which one?
Line number 6.
Line number 6. Ah, yes.
See, we're just calling command of list, right? We're just calling
Self dot commands is a dictionary.
Yes, yes.
Dictionary of.
If you do list directory,
Oh yeah, list that. Yeah.
so
We are never calling the function directly. We will never call list directory, who am I, or any of these functions directly. All of these functions are simply going to be registered into this shell. Oh, some loose contact here.
see, when we do decorator shell dot command of list, right?
Yeah.
So it will register with that object, PyShell object with the command method, right?
Yes. See, when I say shell dot command of list,
Yes.
what exactly happens?
It will go to the
First, this
object.
particular will go to this.
Yes, and register with the object,
No,
the parameter list. C is the parameter.
C is actually C is a list.
It will,
Yes.
it will
Yeah.
be listed. It will
Yeah,
be,
list.
Registered that.
Yes.
It will be registered.
Basically, it will not register immediately.
Okay.
Basically, this command is called with list as an argument.
Yes.
This
sir.
command returns decorate.
So this function,
Decorate is called, when decorate is called, decorate will be able to see C via nested static scope. Fn is a parametric variable.
See, that's where I'm thinking. See, if you do invalid, right?
Mhm.
If you do def invalid of self comma function.
Okay, you know what? I'll run it via debugger. You'll know that.
No, we're just calling directly. We're passing directly the function which is calling exactly.
Yes, yes.
But in this case, parameter.
Yeah.
So we're calling just parameter first. Then again in the inner decorate method,
Yes.
we're calling function again. So
You're not calling the function.
no, it will pass the function automatically.
Yes.
So how it will be differentiated from this one and that one? So if you have parameter,
Mm-hmm.
so first it will register the command self comma C.
Mm-hmm.
Then it will call in the decorate function.
Same rule. Anything that you call here
Yes.
must return a decorator.
Okay. Yes.
If
correct.
you are calling, it must return a decorator.
Correct, correct.
Are we following the rule?
Yes.
If we are calling it, it is returning decorator.
Correct.
What a decorator is returned will take the target function as an argument.
Okay.
Am I correct? What you do with the decorator is up to you. Whether you create a wrapper for it. In this case, I'm not interested in creating a wrapper for the original function. I want to register in a lookup map. I want to register in a dictionary. Because it's through the dictionary I will call the function eventually.
Is it not possible to write Fn in the command line, in the fifth line itself?
Where? Fifth line. It'll not work. It'll not work.
Here it works, right? Invalid self comma Fn.
Ah. Invalid Fn, right? This one. You're talking about invalid?
Yes, yes.
How is invalid used? Am I calling invalid?
Yes, somewhere you are calling down.
Am I calling it?
Yes, invalid. Yes.
Am I calling it?
Correct.
Am I calling it?
No, you just define that.
Is it open close parenthesis? For command is open close parenthesis,
Yes, yes.
which means I am explicitly calling it. Because I am explicitly calling it, whatever that function returns, the annotation will call it once again.
Fine, got it.
Here,
Got it, got it.
I am not calling it, directly the annotation will call it. Know the subtle difference, okay? Parameter decorator means you are calling a function, and whatever function you call returns a decorator function.
Okay, got it.
Invalid is not a parameter decorator.
Yes, good.
You are not calling it, who's calling? Python is calling because of annotation syntax. And invalid is very rigid. You know why? Because it will only take one argument, one extra argument in this case. Target function decorated. Whereas this is flexible. You can take one argument, 10 argument, 100 arguments, depending on how you implement the prototype. You are implementing the prototype, am I correct? So you can take any configuration. That's why it's called as parameterized. You can send parameters for the decorator. Clear with this? Any questions? I'll paste this. If you're new to Python and you want to, in the learning stage of Python, learning all this logic will take some time. So the best way to learn it could be using debuggers, right? If you want to learn it to a debugger, Python comes with a built-in debugger called PDB. But I like a better debugger than this today. I recommend you to install a debugger telling pip3 install PODB. PODB3 specifically, right? It's actually more it will be more intuitive for the user. It will give a TUI, textual user interface, so you can debug the entire program. Like say, for example, I'll just say PODB. See, it's called PODB3 because you install for Python 3. Run this program, PyShell, what is it called? Okay, deco exercise, right? Deco exercise of P1. See, launch that particular program in one textual user interface nicely. That cursor, right? That arrow mark shows line number 1. Line number 1 is highlighted. Line is in line number 1. That means it will start defining. What is the first line there? It's a definition, class definition, am I right? So you can start stepping line by line by pressing N for next, right? N will just define, or you can say yes for step into if you want to. In this case, whether you step or next is okay. Since I said yes, yes here. Oh, not working. Hang on, should work. N, okay, I said N. So it's defined this particular class, right? Now this class is being defined. Now this shell is equal to PyShell. See there it shows all the variables defined. There's something called PyShell which is a type. Shell is equal to is of PyShell type, right? Then when I say shell.command, this you can step into because you want to see how it actually runs. Next will basically step over. If it's yes, right, the step into. It's a shell.command of list. Just see what happens now. So it goes inside command. Inside command, right? C is equal to list, self is equal to PyShell, right? Self is of type PyShell. So you can see over here, it's inside decorate. So decorate is defined, returns decorate. The decorate is returned, but again the decorate is called by who? What? By what? By the annotation. And what this decorate does? Self.commands of C is equal to FN. Now you can once you can see this. Self.commands C is equal to FN. Now you can actually go back and see the value of this variable. Where you can see that you can just tab. No, it doesn't go. Yeah. Okay. The command that I used was called as PODB. I'll show you that again. PODB3. You need to install this tool by doing a pip3. See that pip3 install PODB. But if you don't like a textual user interface, you want to work in low-level command line, don't install anything. Standard Python comes with its own built-in debugger, which is like GDB or JDB, if you know about this command line debuggers, right? You can say Python 3 -m PDB. This is built into Python. No third-party, it's built into Python. Then you can say PyShell deco exercise.py. See, class PyShell. You can say L for list. Some shortcut commands that we understood. You can say H for help.
There's something called PyDevD also.
Yeah.
PyDevD.
PyDevD is part of Eclipse plugin. I would not even recommend using it. If you are on Python environment, the first thing you should avoid using is PyDev. Eclipse. It aims you to write Java programs in Python. it makes you write Java programs in Python. So I would not recommend it. Stay away from it. Most people start developing Python using PyDev. You know what they do? They'll get a project, they'll get classes, they'll get methods. Typical Eclipse workflow, right? They'll get that workflow and they will make a bloated application, Python, that looks like a Java application. Lot of classes and hierarchies. And then wonder, why is Python slow? Why is Python so complicated? Because you're not doing Python the Python way. Avoid using the PyDev family completely. You see this IDE that I'm using? Spider. SPYDER.
But if you're trying to do that, it's trying to go to GitHub actually.
Which one?
If you try to download that, it's going to GitHub.
The best way to have your interface, right? If you're working on Python today, don't struggle with all independent tools. Go and download Anaconda. If you're new to Python, install Python from Anaconda. Everything will come in a dashboard. Click on the download link. and you can download for Mac, for Windows or Linux. This is a very big download. It comes from about 563 MB. But I tell you what, it gives a better interface called IPython. Gives you Jupyter Notebook, gives you Spider IDE, gives you Jupyter Lab. Plus, it contains all the libraries that you need for data analytics, data sciences, and machine learning.
This is ID with Python.
It's a complete package, a distribution, Python distribution. It comes with IDE.
You don't
Want to
recommend
install
PyCharm?
supply.
Yeah.
PyCharm.
I will not recommend PyCharm for one single reason. PyCharm is a commercial product.
No, there is an open source.
No, there's no open source. There's no open source.
Community edition. I use.
It is illegal to use community edition in a company.
Okay.
You know that? If you're using community edition in Cisco, and if PyCharm folks knows it, JetBrains, they can sue you. Beware. The JetBrains company, right? The PyCharm community edition is only for developing open source products that will be uploaded in GitHub. You should not use it for commercial and enterprise use cases. You should get enterprise license. That's why I don't recommend PyCharm. I mean, you're okay with working with closed source software and you're willing to pay a huge amount of licensing fee for an IDE, go ahead, do it. But you have free alternatives. Spider is good. Spider is equally good. A lot better than PyCharm, I felt, at least. It's good for data sciences, at least if you're working on analytics and so on, quick snippets and so on. It's good. Go with Anaconda, it's free. Open source. Okay? So this is. Most people have been using PyCharm simply because it gives a nice interface, lightweight interface. But you know what? Strings attached. I've seen many companies getting sued by JetBrains.
Oh.
Beware. And if you're using PyCharm, I'm sure your manager doesn't know it. Your manager knows it. If it's coming from a legal department, they'll tell you to get a license for it or not use it. Very important. Know that. Okay. Some people even use, if you're comfortable using Vim editor, you can use Vim with Python plugins. If you're using Vim editor, right? Vim can be converted to full-blown IDE. In fact, there's a way to do that. Just search for Vim Python. The first link, Vim and Python, match made in heaven. You can see this. It'll tell you all the plugins for Vim editor that will make it Python friendly, right? If you're using Emacs editor, there's something called LPy that also you can use. I mean, people who are from Vim and VI, VI and Emacs folks, for them it's okay. But if you plan to use graphical user interface kind of things, then you stick to Spider, it's easy.
Sublime.
Sublime is only an editor.
No, you can install some.
You will have to install extra plugins and other things. And Sublime also is not open source. It's also commercial. And there's a community edition that can be only used to develop open source projects. All of these are strings attached. Beware. Right? If you think you want to use Sublime and you want an open source equivalent, rather use Atom. Atomator is a fully open source project. Atom, brackets, there are many others, right? Those are generally editors. But if you're looking for something beyond editor, a full-blown integrated IDE, the Spider comes with all the things that you look for Eclipse, right? You can things like, you can run a program, you can even run the debugger in Spider. See this? I was trying to debug it through a command line. Even in Spider, you can debug it. You can see over here, there should be some debug option. Okay, here you can see this. You stepping over line by line, you can do that. All these options are available in this. Okay.
Can you show how to download Spider IDE alone?
Well, for a Mac, you need to first install Homebrew. You have Homebrew installed? Without Homebrew, it will not work.
Install Spider.
You need to install Homebrew. Then you say, first you do a brew install PyQt5, PyQt5, and then you say pip3 install Spider 3 or Spider. These are things. Without Homebrew, one more thing, if you're working on Mac, don't use the default Python that comes with Mac. The default Python that comes with Mac is optimized for running your Mac services and applications. So many times you'll go and install some extra libraries, extra packages and so on. I've done this before. I'm not sure about newer versions of the Mac OS. I remember in Snow Leopard days, I used to install a lot of libraries on the system Python that comes with Mac. Eventually Mac stopped booting. Because some particular library got updated, which perhaps the launchd services did not like. The launchd services broke. Mac stopped booting. When I went to the forum, they said, some of these services got updated because of Python. Stack Overflow somewhere. I got that forum information. So the hint is, if you're using Mac, install Python separately. Okay, install Python separately. One way to do so is by using the Homebrew, right? I think it was brew.sh. Go to brew.sh, you can install Homebrew package manager. There's a procedure for doing this. You have to spend a day. Today evening, you can do this maybe. Install Homebrew and say brew install Python 3, brew install Python 2. You can do that. But if you find all this too cumbersome, easiest way to get Python fully productive is simply downloading Anaconda and installing, either for Mac or Windows, for both. Okay. Anyways, I think I told you about this example. So have I pasted this? Yes, I think I should have even pasted this code for your reference, right? Have a look. So I told you can debug this program, run through debugger and get to know the complete flow control of how this program works. This, let me tell you, itself is a design pattern. What I showed you is a design pattern. You know what this design pattern is? Actually, it's called as a command pattern. It's a variation of an event delegation pattern. So you can see this is like an event. For this event, the function that must be delegated to is this. For this event, the function that must be delegated to is this. It's a very common use pattern. I'm going to show you one readily available framework that uses the same design pattern, exactly the same thing. And that is a very popular web application framework, I say minimalist web application framework called Flask. If you install Flask framework, right, you can say pip3 install Flask, just see this. I can say from Flask import Flask. The Flask is like that PyShell class, right, similar to that. App is equal to Flask of my app. Give any name that you like. Shell is equal to PyShell. We did this in our code, right? Remember? Similarly, here I say Flask is equal to, app is equal to Flask of my app. And then I'll define a function. I'll say home page. This home page function, I'll return h1 hello world. Some HTML tags, right? Def about page. Return. This is about page. Right? And what I do over here, I'll say @app.route of slash. Here I'll say @app.route of slash about. Looks very similar to shell.command of list. Am I right? Same way I'm wiring over here. Here I'm wiring for different URLs. And then the URL path I would say. In the main namespace, I'll say app.run, shell.run, right? Say exactly similar pattern, right? Let's just go and develop. I'll run this program and show you what happens. Just see. Python 3 Flask hello.py. It launched a web server listening on port 5000 by default. You can change that by telling app.run of port is equal to 8080, any number. I'll go to a browser now, real web browser. HTTP localhost : 5000. What happened? This function got called. Which one? Homepage. Whatever this function returned got rendered. The moment I say the URL with slash about, URL has slash about, right? Typical MVC, right? Model view controller. You see, in this Flask is only majorly worried about the view and controller. So the controller wiring is done by an event delegator. This is taking care of the controller path. For slash, what view must be generated. For slash about, what view must be generated. And how do you think it's done? Exactly similar logic which I have here. Exactly similar logic which I have here. Except that in my shell, input is handled by user input. In Flask, input is implicit. It'll handle it via network sockets. Open a socket connection, let's a socket on port 5050. Look for what kind of request you send. If it's a GET request, do this. That will be taken care by the input. Understanding this? This pattern is very commonly used in MVC frameworks. Even if you're trying to implement a graphical user interface with a lot of menu options, right? For this menu, call this function. For this menu, call this function, right? The lookup maps are done using a pattern similar to this. Clear? Any questions? Doubts so far?
Is there any baggage with Flask?
any disadvantage? Using it in a big project.
You will never want to use Flask to create your next e-commerce application. You'll just waste a lot of time. There are two ways to develop web application. One, model first approach. If you're developing a next e-commerce application, you'll not start bottom up, you'll start top down. What is top down? You'll first worry about what are the views that you need. You worry about information architecture, UI flow diagrams. You create the models for the information architecture that you create. Wire up all the models. The models are nothing but databases ultimately, data entities. They're working with CRC, blah, blah, blah. And after that, you'll worry about creating an application to wire them up. If you're using that kind of an approach, it's recommended that you go for full stack frameworks like Django in Python. Better than Django, I will say, could be Ruby on Rails. That's most popular, right? Ruby on Rails, Groovy on Rails. These are full stack frameworks. They are very well suited for these kind of scenarios. But assuming that you have some application running, you develop some application. Maybe you have created one testing engine which is running some test cases. For testing application, you want to provide a web-based frontend to show some reports. That's where you go for Flask. Flask is suitable for these kind of scenarios. It's a minimalist web application framework, which means it doesn't come in your way. It only gives you the view controller wiring, which are very basic HTTP helpers, cookies, sessions, and other things. So it's pretty easy. So if you're developing application using the top-down approach, as I told you, this can be cumbersome. Why? Because you'll have to write everything on your own. It doesn't tell you how to connect to database. You have to worry about database connection. If you use Django, you don't have to worry about database connection at all. You create a model via Django. It will take care of all the database wiring appropriately. Like we say ORMs, right? In other languages, the ORM is built in Django. We call ORW there.
SQL Alchemy.
Yeah?
SQL Alchemy.
Yeah, Django can work with SQL Alchemy also. It has plugins to work with SQL Alchemy, or it can also work directly with its own Django's active record, which is even more easier than SQL Alchemy. Django has plugins to work with different kinds of data engines. You just have to set configuration. Very basic configuration. Okay? So it follows a conventional configuration, actually speaking. So it's just mostly on active record, but you can change it. Flask, it is completely flexible. It's a difference. Okay? Any questions, doubts about this? Right? I showed you some examples of how you can use decorators and showed you some design patterns on this. We'll break for lunch. We'll get back after lunch. We'll try to make it by 1:40 if it's possible. Okay? 1:40, 1:45. I know I should have left by lunch by 12:30. Sorry. So fine. Once you come back from lunch, I will show you some more examples for EOP patterns and decorate some 2 or 3 examples more, design patterns again, and then talk about comprehensions, generators, coroutines. 3 important topics. Okay, post lunch.